Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Fikri bin Shafi'i and my mention number is DE190143. Today I will present about the mathematical analysis for circuit, which is group assignment. This is my team member Akif Rushaidi bin Azim. Okay, without further ado, I continue for the mathematical analysis. And then this is our circuit. This is the AC source. This is a DC source. We have resistor, inductor, capacitor, and resistor, and also inductor. So for the first step, we change the original circuit into frequency domain circuit in order to find the current equation for each loop, and then we use mesh analysis to find each current equation for each loop. So at loop 1, we get the equation is I1 equal to 2s I3 minus 75s divided by 10 plus 2s. So for loop 2, I2 equal to 20 minus 10 I3 divided by negative 10. And then at loop 3, we get 10 plus 10 over s plus 2s times I3 minus 10 I2 minus 10 over SI4 minus 2 SI1 equal to 0. And then at loop 4, we get I4 equal to 10 I3 divided by 10 plus 2s square.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akif Rushaidi bin Azim and my metric number is DE190184. To get I3, we can substitute I2, I1 and I4 from the circuit that we get from mesh analysis into I3, and we get a general equation which is 10 plus 10 per s plus 2s multiplied by I3 minus 10 multiplied by 20 minus 10 I3 per negative 10 minus 10 per s multiplied by 10 I3 per 10 plus 2s cubed minus 2s multiplied by 2s I3 minus 75 per s per 10 plus 2s equal to 0. By simplify the equation above, that we get negative 4s squared minus 42.8s per 0.4s cubed plus 2.4s plus 0.4s minus 8 equal to I3. And by implementing the partial fraction, we get that I3 is equal to 4.453 per s plus 5 minus 5.183 per s plus 2.56 minus 3.452 per s minus 2.56. And we can convert the I3 from frequency domain into the time domain, which is 4.453 exponent negative 5t minus 5.183 exponent negative 2.56t minus 3.452 exponent 2.56t. And from I3, we can get I1 by substituting I3 into the I1 general equation, which we get 2s multiplied by 4.453 minus s plus 5 minus 5.183 per s plus 2.56 minus 3.452 minus per s minus 2.56 minus 75 per s per 10 plus 2s, which we simplify and we get 8.906 s per 2s squared plus 20s plus 50 minus 10.366 s per 2s squared plus 15.12 s plus 25.6 minus 6.904 s per 2s squared plus 4.8 s minus 25.6 minus 75 per 10s plus 2s squared. By implementing partial fraction, we get I1 equal to negative 41.39 per s plus 5 minus 4.453 minus s plus 5 square plus 106.72 per 25s plus 64. And we can inverse Laplace it into time domain. We get negative 41.39 exponent negative 5t minus 4.453t exponent negative 5t plus 4.2688 exponent negative 2.56t. And from I3 also we can get I2 by substituting I3 into I2 general equation, which we get I2 equal to negative 2 plus 4.453 per s plus 5 minus 5.183 per s plus 2.56 minus 3.452 per s minus 2.56, and we can convert that into time domain, which we get negative 2t plus 4.453 exponent negative 5t minus 5.183 exponent negative 2.56t minus 3.452 exponent 2.56t.
Okay, from the previous calculation, we get the value of I3, and then to find I4, we need to substitute I3 into I4. So I4 equal to 10 times 4.453 divided by S plus 5 minus 5.183 divided by S plus 2.56 minus 3.452 divided by S minus 2.56. The overall equation divided by 10 plus 2s square, and then we get the final frequency domain equation, which is this is the final frequency domain equation. And then in order to find the current I4, we need to apply partial fraction for each of the frequency domain equation, and then we use inverse Laplace in order to get the time domain form. So after we apply partial fraction and inverse Laplace, we get the I4 is 0.7427 exponential negative 5t plus 3.641 over square root of 5 sine square root of 5t minus 0.5927 cos square root of 5t minus 0.08972 exponential negative 64 over 25t minus 0.05976 negative 64 over 25t ampere. That the value of the current I4. For the next part, we need to find the voltage for each component, which is R, L, and C. So from the equation of the current, we can find the voltage. From the value of the current, we can find voltage. So we can find the voltage for R1, which is 10 ohm. V equal to I1 R1. So the I1 we get from the previous calculation, which is this is the value of I1. We times it by 10, and then we got the final equation for the V in the frequency domain. So from this frequency domain equation, we need to apply partial fraction and inverse Laplace in order to get in time domain. So for the VR1, we get negative 413.9 exponential of negative 5t minus 44.53 t exponential of negative 5t plus 42.688 exponential of negative 64 over 25t volt. So this is the equation. This is the value of VR1 for VR1. So for voltage for L1, which is in the inductor 2H, the equation is VL1 equal to I1 minus I3 equal to the impedance of the inductor. So this is the value of I1 minus I3. You get the equation for I1 minus I3, and then we multiply it with 2 over S, and then we get the final equation in frequency domain. And then in order to get the VL1 in time domain, we need to apply partial fraction for each of the equation, and then we need to use inverse Laplace. So the final answer for VL1 is equal to negative 18.3372 UT plus 18.3372 exponential of negative 5t minus 0.35624 UT plus 0.35624 exponential negative 5t plus 1.7812t exponential of negative 5t plus 3.335 ut minus 667 over 200 exponential of negative 64 over 25t plus 5183 divided by 128 ut minus 40.492185 exponential of negative 2.56t minus 2.696875 ut plus 2.696875 exponential of 2.5 t volt. That's the answer for VL1.
For the voltage across the inductor, the second inductor is 2s, so 2s multiplied by I4, which we get 2s multiplied by 0.7427 per s plus 5 plus 3.6341 minus 0.5927 s per s squared plus 5 minus 2.243 minus per 25s plus 64 plus 1.4939 per 25s minus 64, which we get the equation is 1.4854 s per s plus 5 plus 7.2682 s minus 1.1854 s squared per s squared plus 5 minus 4.486 s per 25s plus 64 plus 2.9878 per 25s per minus 64. And we can convert this into time domain, which you get 2854t minus 24270 exponent negative 5t plus 1854t plus 18474 cos sec 5t plus 1854 sec 5 sin sec 5t plus 7776t minus 199.06 exponent negative 2.56t plus 790 exponent 2.56t. And for the voltage across the resistor, the second resistor, which is also 10 ohm, we get 10 multiplied by I2 minus I3, which is negative 2, so negative 20 volt, and convert it into time domain, which is negative 20t. Voltage for the capacitor, which is 10 per s, is 10 per s multiplied by 1.001 per s plus 5 minus 5.183 per s plus 2.56 minus 3.452 per s minus 2.56 minus 3.6341 minus 0.5927 per s squared plus 5 plus 2.243 per 25s plus 64 minus 1.4939 per 25s minus 64, which we simplify it and then we convert it into the time domain, which we get 2.002t minus 2.002e exponent negative 5t minus 20.25t plus 20.25 exponent negative 2.56t minus 13.48t plus 13.48 exponent negative 2.56t minus 7.2682t plus 7.2682 cos 2.23t plus 2.6506 sine 2.236t plus 14.78t minus 14.78 exponent negative 2.56t minus 205.4t plus 205.4 exponent 2.56t.
For the next Fourier series, we know that the our source is V equal to 75 and the frequency is 50 Hz and the AC, and it use AC signal. So from the frequency, we can obtain the period, which is t equal to 1 over 50, and we get 0.02 second, which means the one complete cycle of this graph is at 0.02 second. So the amplitude is 75. From there, we can get omega naught is equal to 2 pi over t, and 2 pi over 0.02 we get 100 pi. And then from there we can find a naught, an, and bn. Because this square wave is odd symmetry, we can assume that a naught and an is equal to 0. From the calculation, it prove that a naught is equal to 0 and then an is equal to 0. So we just need to find bn. So for bn is equal to over 0.02 integration from 0 to 0.01 75 sine omega t plus integration of 0.01 to 0.02 negative 75 sine n omega t dt. So the first step, we factorize the 75 for both integration, and then we get 7,500,000. And then we integrate the integrate of the sign and integrate the left side and right side, we get negative 1 over n 100 pi cos n 100 pi t from 0 to 0.1 plus cos n 100 pi t divided by n 100 pi from 0.01 to 0.02. Okay, and then we need to apply even and odd. So for the bn, we know that the even equation, the value if we apply even number, we get the equation will become 0. Therefore we don't need to find the even number, and then we need to find the odd number, which is from 1 2 3 1 3 5 7 and so on. So from there we get the final bn equation is negative 75 over n pi, and then the final equation for the bn is 75 over pi sine n omega t minus 75 divided by 3 pi sine n omega t minus 75 over 5 pi sine n omega t and so on. So that's this is the final equation. It can be write into two form. That's all. Thank you.